Hello, my name is Tyler Crabb,
And I'm Dave Pipkin.
and together we redesigned the controller for the Widmann Automatic Shell Pacer, or the WASP. This machine is used in the pyrotechnic industry to wrap ball shells which are fired from a cannon into the sky. A ball shell looks like this. These are the two cardboard hemispheres that are filled with pyrotechnic elements. This particular one is called a star. It's not been coated in black powder, so it's not dangerous yet. But it'll burn it at a couple hundred degrees and give us a nice red color. The ball shell is packed with black powder rice hulls with a charge in the middle that explodes and ignites all of the elements inside the ball shell. For this to happen effectively, the ball shell needs to be wrapped tightly in a glued paper format, which is what you see here. This paper goes around and around the ball until it can cure into a nice tight formation. This ball can then survive the intense force that happens when it's shot out of a cannon a couple hundred feet in the air, so that it can explode and look pretty. The concussion force inside the ball also has to ignite all the elements so that a firework explosion looks symmetrical and cylindrical, spherical. Besides, anyway, this system really needed some improvements because the old controller looks like this. This contains the stepper motor drivers as well as the logic controller. This is just the power supply that drives these large NEMA 23 stepper motors. There's two of them, one here and one on the other side, driving these wheels. This old implementation is no longer commercially available, so the manufacturer of this machine is in a bit of a tight spot because he can't produce product anymore. It also required an old Windows XP laptop to be able to run, which was cumbersome and difficult for users to navigate. So we decided to replace all of the driver controls with our microcontroller.
Hey, so as Tyler mentioned, the scope of our project was to program everything using our microcontroller and the different peripherals we have to control this the awesome device we have. Let's see here. We have, first of all, our user input. We had the idea to use a Super Nintendo controller to make it really easy and fun to use. However, when we got into the logic analyzer, we noticed we're having issues with how the data was being read into the latch register and getting timing issues with the SPI protocol. So we decided to go back to the Digilent keypad, as many of you are familiar with, was used in digital system design, and it makes for a really nice user interface anybody can use. With we have a 4x20 Hitachi LCD, and so we have all our different menu options on here. Allows the user to be able to pick the different ball size diameters that they're going to be using, as well as be able to check be able to select, whether it's a burnish or the normal wrap cycle. Of course, we have the brains of our operation, the STM32 microcontroller. Here on the proto board is where we have all the connections made, along with some resistors and the components like that. We've got our stepper motor drivers, so those are controlling the direction of rotation for each stepper motor, as well as it's sending it's controlling speed by the number of pulses that we're giving, the pulses per revolution, and that can be configured as well with different settings on the dip switches. And then we have our power supply for our stepper motor drivers, a 48 volt power supply. And then the whole device here, and the WASP controller, and the wrap. And Tyler's going to take it from here to show our demonstration.
So, as you can see, the paper starts here. This is already glued paper. It's glued on one side and then wet on another. If you've seen an Amazon box, it's often wrapped with this kind of paper. So this water and sponge mixture just wets the paper as it travels along the underside of the WASP. There's some rollers, some rolling pins here, and the wetted paper has had enough time at this point to soak in and really get the glue nice and sticky so that it can tack onto the ball shell, which is, this one's inert, there's nothing in this one, it's hollow, but usually it'd be loaded with explosives, so no smoking please. If you come over here to the menu, we tried to focus on the user interface to make it really nice and easy for anybody to walk up to this setup and operate the Wasp. So, just as it says, follow the instructions. Press any button. I can press any button, and it'll take me to the main menu. Here I can select either wrapping a ball shell or a technique called burnishing the ball shell, which I'll show you later. So, if I press the number 5, I can scroll up or down. The number 4 works as well. I'll come up here to wrap ball shell. On here, we tried to map the number 7 to the A button on the SNES controller, and the number 1 to the B button, and then this row 4, 5, 6, and B were our corresponding up, down, right, and left buttons. But we had to improvise a little bit. So if we press the number 7, this will allow us to select any size of ball shell that we want. So let's scroll over. What size ball shell do we have today? This particular unit that we have is a 6-inch. But if I accidentally decided to select an 8-inch ball shell, the machine doesn't start yet. I have a chance to go back if I want to. Oh, oops. Let's select the right size. So now, the menu asks, are we ready? At this point, we're ready to wrap. So let's press the number 7 to begin a wrap. We'll see a nice countdown. Then, the ball shell paster will start to turn. It'll apply this paper, this wetted paper, as evenly as possible across a spherical surface. It doesn't do a perfect job, but it does a pretty fine job. If you come over here, we'll see that we're also measuring, or giving the user an estimate of how much time is left before the ball shell is done wrapping.
Okay. We've also implemented in our design an emergency stop using a manual interrupt. So let's say if someone were to come in, maybe the kid were to go and put their hand in there or something, you can push any button, any key on here, and it will immediately pause and stop the machine. And then you can push 1 to cancel the operation, or you want to resume and just push 7 and we'll go back to wherever it left off.
So we're going to stop this ball shell just for purposes of demonstration, and I want to cancel. Now, if I wanted to, I can now choose to burnish a ball shell. A burnish comes through and it spins the ball very quickly so that all the space you see on this paper will be tamped down so that this ball shell will fit better and better inside a mortar tube. And Dave will show that off.
Okay, so we're going to simply select burnish right here. Push 7 is going to be select, and we go over to, we've got the 6-inch. Okay, ready to burnish. Push 7 to begin, and gives a countdown. There we go. So, and as we can see here, it shows that we've got about 12 seconds remaining on that.
This is a very rapid process.
The idea is about the same number of revolutions, but because it's a lot faster speed, so it's going to take less time for this cycle.
So now, if I choose, I can lift the top arm away, pull my finished ball shell out, And now I'm able to cut away into the paper to find the fuse that I've buried inside of there and stick my quick match on top of that. And this bad boy is ready to fire. Anyway,
All right.
so this is our project, the Widmann automatic shell paster. We're so grateful to have the opportunity to work on it.
Thank you for watching our presentation.